So, hello there, all of you. My name is Siddesh Valekar, and today we gonna learn the continuous uniform distribution. So, in a continuous probability distribution, there are four types of distribution. We see one of them. It's called as continuous uniform distribution. In a probability theory and statistics, the continuous uniform distribution is a type of probability distribution. It describes an equally likely outcome within a given range. So that's all on a first page. Now let's move on a second page. So on a second page there is a PDF, means probability density function. The probability density function for a continuous uniform distribution is a constant function. Over it supports representing an equally probability of all outcomes within that interval. This function is used to describe the likelihood of obtaining a particular value within a range of distribution and essential for understanding and distribution behavior. So this is the PDF, means probability density function. Now we gonna move ahead. After the PDF there is a CDF, means cumulative distribution function. Cumulative distribution function gives the probability that random variable less than equal to the certain value. It's nothing more used in this, but still we gonna see this. Now let's go to the next page. There is a mean and variation of this distribution. Mean of the distribution is that uniform distribution is calculated as the average of the minimum and maximum value. It means like two variables a plus b divided by 2. Now we move to the variance of this distribution. The variance of this distribution is calculated by a formula. Let's assume two variables a and b. So in this formula we're gonna do the subtract the a into the b, or it divides by 12 and the square, sorry, not a square root, it's a square of them. Thank you. So now let's move to the another page. Now let's see the property of this distribution. The first property is that equal probability. Each value within range has an equal probability of occurrence. It means all has a equal occurrence. Now second property is a constant probability density. The probability density function is a constant within the range, means between this range the PDF remains constant. Now we're gonna see the next property is a rectangular shape. The probability distribution graph is form a rectangular or illustrating uniformability, means the graph is represent in form of rectangular shape. That's it. Now we're gonna see the independent events are independent as the outcomes for the one event does not impact other. It means their events are individual, means there is suppose there is a four outcomes, but none of them affect each other. That's the independent events. Now we're gonna move ahead. Now we see the application of continuous uniform distribution. This distribution used in various type of fields, but we see few of them First one is a stock trading. Second one is a random number generation. Yes. And third is a weather forecasting. That's the few of them application. Now we move ahead. Here is the comparison with other probabilities. Continuous uniform distribution has a constant probability density over a range. Normal distribution has a bell-shaped curve. Then equal likelihood across the entire range. Most value cluster around the mean. Used for modeling random variable with no bias. Used for modeling variable nature phenomena. And last one is simple to understand and apply, well studied and widely used in a statistic. For your kind information, normal distribution is one of the distribution in a continuous probability. So they uniform distribution and normal distribution are compared to each other in this page. So in next page there is a example of continuous probability distribution. First example is a rainfall in a forest. Second one is a sand dunes in a desert. And third one is a seed dispersal by plants. All these are the examples of this uniform distribution in a real life. Now we gonna see the limitation and assumption of the distribution. The first limitation is the equal interval assumption, means assume each interval has the equal probability. Second one is a limited applicability, means may not model a real world distribution accuracy. Third one is a continuous domain assumption, assume a continuous range of possible outcomes. And third one is a independent event. That's all we see earlier. Now we at the last point is that the conclusion and key takeaway. The key takeaway is that the continuous uniform distribution is a basic probability distribution, and with the constant probability density over in interval. That's it. Now we move to the practical uses. Understanding the distribution is essential for various statistical and engineering applications. It's used in a various statistical and engineering application. Now the conclusion is that it provides a simple model for a situation where all outcome and interval are equal likely. There is a simple conclusion, not so difficult. And key property is that its simplicity makes a fundamental building blocks in a probability theory and statistics. Thank you. This is all in continuous uniform distribution. Thank you.